Welcome to the next session of the Hard Surfaces talk. I'd like to introduce Andres Hernandez, who is responsible for marketing for España, whose stand is around here, who are here promoting Coverlam Top, which is their Worktop brand. And he's going to talk us through the evolution of new products in this fast developing and very exciting sector of the tile market. An inspiration of how new technology is being used to create basically a whole new market sector for our industry. Thank
you very much for the introduction, Joe. Well, hi to everyone. Welcome to this presentation. I see mainly natural stone specialists here, perhaps some fabricators, importers, some kitchen designers. As experts on your field, you might know that natural stone is safe by nature through the combination of high pressure and temperature, and depending on how nature combines those two factors, we can obtain a product with certain aesthetics and certain technical properties. Now I ask you to imagine that we could use pressure and temperature to produce a product of better properties, okay, with the aesthetics of our choice. Imagine a product lighter, easier to clean, harder, installable indoors and outdoors. Imagine a product with the aesthetics of the more delicate Brazilian quartzite. Well, you don't need to imagine too much, you just need to pay attention to the following presentation because I'm going to show you how we do it. But before I start, I would like to make a brief introduction to the company I work for, España. We are a ceramic tile manufacturer based in Spain with more than 45 years of history. We are 500 people. Of this workforce, 80% is based in Spain. The remaining 20% is on the locations in which we have operations. As you can see on the chart there, we have 5 distribution centers in Spain, 5 distribution centers in Europe. One of those is in Birmingham. And also we have sales offices in Miami, Chicago, Singapore, and Mexico City. Okay? We have a production capacity of 14 million square meters. We are one of the top 10 ceramic manufacturers in the world, and we are considered as a high-end manufacturer. But that's an image of the company through the main operational indicators. I like also to mention the values of the company. First of all, design. We have a team of designers whose goal is to travel worldwide, identify trends, and develop products adapted to these trends. Thanks to that, we are a company that defines the trends in the ceramic industry. The second value is quality, and I will make it as simple as possible. Ceramic tile manufacturers, they often work with quality controls aligned with ISO standards. Our quality controls are twice stricter than ISO standards. That means that many times a product that is considered second choice in España compared to our competitors is considered first choice. That's a way of guaranteeing a quality to our customers. The third value is service. Service through availability of stock, 6 million square meters of security stock in Spain, regional warehouses in almost every single country in Europe. So you place an order, you got it in 48 hours. And also a sales force distributed worldwide, so we are in the same time window as our customers, and we can give a quick answer to our customers. The last value is innovation. We have a budget of 3 million euros per year on research and development. Thanks to that, we have been pioneers on many of the ceramic industry innovations in the last 20 years, and Coverlam is one of those. This presentation has 3 main blocks. First of all, I wanted to give a clear definition about what Coverlam is, and all the products that compete on the same segment in the industry. Secondly, we will talk about the design process that we follow, and last but not least, the manufacturing process. So moving to the definition of the product, depending on the way manufacturers brand it, you can find several definitions. Some people will say they have an engineered surface. Others will say they have a superior natural surface. Others will focus on one feature and will say it's an ultra-compact surface. There's other people who want it all at the same time and they claim they have the largest compact surface in the world. And then it's ourselves, which are also guilty. We say we have technical stone. But what is it in reality? It is porcelain. And according to ISO standard definition, porcelain could be said that is any ceramic material manufactured with high pressure and temperature with a water absorption lower than 0.5%. But if we want to go one step beyond with the definition, we could say that generally speaking, porcelain is a combination of 2 layers. An upper layer that we call glaze, okay, applied in liquid status that has the graphics and the pattern that we want to imprint on the product. And then a second layer, thicker, called biscuit, which is a combination of two porcelain clays, granitic clay and feldspathic clay. And we don't pick up the raw clay from the mountain and put it into the production process. First of all, it has to go through a chemical process called the spray drying. So we reduce the clay to a certain particle size that we call porcelain powder. With porcelain powder, we can get a good compactation to produce porcelain. But up to this point, we could be talking about traditional tiles. What's the difference between traditional tiles and large format porcelain slabs? Well, it's the production technology. It changed 15 years ago. On the lower part of this slide, you can see the typical porcelain production process. It's a four-step process: pressing, surface decoration, firing, and then quality control. But 15 years ago, we introduced, first of all, a change in the pressing technology, and also we added a new layer to the product. We added a layer of glass fiber mesh to the product. Thanks to that, we are able to produce a product of a size of 1.6 by 3.2 meters on a thickness of minimum thickness 3.5 millimeters to 20 millimeters. Also, very important to mention, with less tension points or with less tension than traditional tiles. But let's go a little bit forward and let's compare this product with traditional kitchen countertop products. If we put all the data together, we will see that, for instance, there are some values in which porcelain can have a better performance than traditional products. For instance, water absorption. Coverlam has a water absorption of 0.1%. We said porcelain is lower than 0.5%, but we can improve that and we can manufacture it with 0.1%. Other products, they have also a good performance, okay, like for instance, granite, 0.2%. But if we go to more synthetic products like solid surface or quartz or marble, in this case, will be a higher water absorption. The next value, weight. Obviously, weight depends on the thickness of the material and on the density. The standard thickness on this product for the kitchen industry is 12 millimeters. On other products, you might go to 20 millimeters. Density, the variation is very slight. So basically, if we focus on the thickness, we can say that our product it has half the weight per square meter than other products for kitchen countertops. The next value is hardness. The best way of comparing hardness is using the Mohs scale, where the weakest material will have a value of 1 and the hardest, which is diamond, will have a value of 9. Coverlam or any porcelain is positioned in the range 7. Okay, it means that only porcelain or other harder materials like diamond can scratch it. Also, very interesting, the maximum temperature resistance. Many synthetic materials will say that the maximum temperature that they can face is 150 degrees. In the case of quartz, it can crack and is not covered by the guarantee. In the case of solid surface, it can melt. Natural materials like granite and marble, they can face high temperatures, but depending on the color of the natural stone, it will leave a circular shade on the surface if we put a hot body like a pan on the surface. In the case of Coverlam, we say in our catalog that the maximum temperature it can face is 250 degrees, but in reality, we have tested up to 450 degrees. But these are all values put there by an engineer. How do we translate this for the end consumer? Well, first of all, lightweight. This is a benefit mainly for the fabricator, and I'm going to explain it really clearly. Imagine you have to install a fabricated kitchen in a 4-story apartment, and it doesn't fit on the elevator. Then you're looking for a material that is going to weigh half as others. Waterproof is synonym also of stain resistance. Why do countertop materials stain? Because any liquid that we drop on the surface might filter through the surface. And then, doesn't matter how often we clean it, we won't be able to remove that liquid, okay? If we have a non-porous material, no liquid will filter, and we will be able to clean it at the first chance we have. Then also, scratch resistance. Scratch resistance doesn't mean it's scratch proof, okay? It can be a scratch, but only by other ceramics or harder materials like diamonds, okay? So if, for instance, we want to try to scratch it with a knife, it will be like a pencil trying to draw on a paper, okay? We will erase the knife, not the material itself. Then frost resistance and UV resistance. That makes our material suitable for exteriors. UV resistance, because doesn't matter how exposed to sun rays is, the color and the original aesthetics won't be modified. And frost resistance, because we have to be aware that porous materials, when water filters through the body and it freezes down, it expands when it becomes solid and it cracks the material, it breaks it. With porcelain, that doesn't happen because it doesn't filter, basically. And last but not least, it's a sustainable material. We use minerals, same raw materials as natural stone, and we consume half the minerals as the natural stone because the thickness is half. So now I think we have a clear definition about the product. I think we are good to go to the most interesting part, which is the design process. Here you can see a sneak peek of our collection. It's not the whole collection, but it's representative of what we have. As you can see here, we have many different designs. We have concrete looks, metallic looks, marble looks. We have also a solid colors range, solid stone looks, natural stone looks. The question here is, how do we end in a collection with this proportion? Well, basically we follow a four-step process. First of all, we need to identify the trends. We need to know what the markets are demanding, what the different sales channels are demanding. For that, our team of designers, they go to different trade shows, they meet with kitchen specialists, with bathroom specialists, and they get ideas. From those ideas, they develop projects. Once they know the products that we need to develop, we source the original materials, okay? We don't buy images that we're gonna edit, we buy materials that we're gonna scan, and then we're gonna edit in the future. That gives us certain exclusivity compared to other competitors. Once we have scanned the original materials, we have a team of designers who spend his whole day and life editing pictures on Photoshop, okay? Basically, we need to make the colors more adapted to the market. It's not the same base that the UK market demands as the base that the American market demands. Also, some natural stones, we can accept that they have impurities. In ceramic tiles, we cannot accept that the material has the impurities of natural stones. So we improve the material with digital editing. And the last part of the process is the industrial trials. Once we have a file with the design that we want to print, we need to select the raw materials that can allow us to have those colors and those effects. As I said, the first step of the design process is to identify the trends. Depending on where we want to position the product, we get the ideas from different sources. So if we want a product for the kitchen industry, we go to Eurocucina in the Salone di Milano in Italy, and we get the ideas. If we want a product, for instance, a marble imitation, regardless if it's going to kitchens or to bathrooms, we go to the best show to see natural stone, which is Marmomac. If we want the best natural stone product for the UK market, obviously we have to come to this show. So once we get the ideas, as I said, we develop the project. We make a list of products that we have to develop, and then we go to sourcing. From now on in this presentation, I'm going to continue with an example of a range that we developed 2 years ago, which is the Taj Mahal. So we identified a need for the American market of this kind of a stone, okay? We went to visit kitchen showrooms and importers in the American market, and we saw that this was quite popular. It was exhibited on the kitchen showrooms. It was on the stocks of our customers, the natural stone. And we decided to buy the slab. For that, we collaborated with a distributor in Spain. We met with him, and he offered us his best slab, the most exclusive one, and we purchased it. Once the slab was in our offices, some of you might think that we use these massive scanners that fabricators use to scan one slab and then do simulations on how a kitchen will look like with that slab. Unfortunately, we don't use that machine. We need more definition, so we use the scanner that you can see on the lower part of this screen. Basically, we need to cut the slab into pieces, and we need to put it on this machine. This machine stays around 3 hours scanning the graphics and also the texture of the product. Once we have finished scanning all the tiles, we get this, that we call the faces, okay? We need to reassemble again all these faces, and then the designers start working on Photoshop. And as I said, they can give more intensity to the color, they can remove veins, they can maintain or remove the impurities. That depends on the taste of our salespeople and our customers who are also involved in this design process. Once we have an optimal image according to the design team, we leave the product in hands of a team of chemical engineers. Having a look to this image, they have an idea of which glazes they need to use. just to give you an idea, this is our library of glazes, okay, sample glazes. Here you can see only the blue ones, yellow ones, and white ones, okay? So they make a combination of different glazes in a porcelain body that they have selected, and they print on top of those glazes. And thanks to that, they can see the performance of the color on every single glaze. Looking at this image, they start to do industrial trials with small samples with the final image until they find the optimal formulation, and with the optimal formulation of raw materials, then they do a full slab. And with a full slab, our salespeople, our customers, and our team of designers, they visit the design center to give their feedback, okay? And some of them might say that it is too busy, has too many veins, maybe it's too beige, maybe it's too gray. And we repeat the process one time and another, and until we've got a product that our customers like, our salespeople like, and obviously our designers like. Thanks to that, we can move from this image, which is the original Taj Mahal slab that we scanned, to this image. That is the final product. So up to this point, we have a file with the aesthetics that we want to print on a ceramic body and the formula. Now we have to start the manufacturing process. As we saw before, it's a 5-step manufacturing process. This is a generalization. You can add more steps, okay, but this is the general process for getting porcelain. So we start with pressing. We need to compact the porcelain powder. For that, we use a pressing machine of 36 tons and a 2-step pressing process of 45 seconds. The time in the pressing machine depends on the thickness. Then we move to surface decoration, is where we apply the glaze, the digital printing, and also we can apply a glossy effect to the product. The next step will be firing, okay, is the critical part of the process. Basically, we work with a kiln whose maximum temperature is 1200 degrees, and the time inside the kiln of the pieces is depending on the size and on the thickness, but on average 1 hour 15 minutes. After the kiln, we apply a glass fiber mesh with polyurethane adhesive, and the thickness of the glass fiber mesh is 0.5 millimeters. And the last part is quality control and packaging, for which we use artificial intelligence and human intelligence. As I said before, the main change in the production process was the pressing technology. This is a typical pressing die for porcelain, and I will make the pressing process very simple. Basically, we put on those gaps here the porcelain powder, we close the pressing die, and we do a vertical pressure, okay? It has 2 limitations, this technology. First of all, the maximum size that we can produce with this is 120 by 120. Secondly, as you can see, the pressing gaps, they have side walls. If there is any irregularity in the distribution of porcelain powder, we won't be able to exhaust it. We will leave difference of density inside the pieces, and that difference will be enhanced in the kiln, because in the kiln the material is going to shrink around 10%. Okay? That difference in density is what we call in ceramics tension points. And if you go to a job site and you see a tiler cutting tiles, you will see that 1 out of 10 is going to crack, randomly crack. That's because the cutting machine has touched one tension point. Okay? Obviously, with a retail price of £1,000 per slab for our material, we cannot have tension points on it. This is the new technology. As you can see, we create a layer of porcelain powder that is going inside this pressing machine. We are going to do a vertical pressure upwards. And inside the machine, we will see that the technology is very simple. We have this deposit here, which is basically for oil, and we have that engine that is pumping oil with a total a total force of 36 tons or a pressure per square meter of 400 kilograms. On top of this deposit, there is a metallic plate of 5 square meters and around 50 centimeters thickness that is leveled by these sensors. And the goal is to fill up the deposit until we transfer all the pressure to the metallic plate. The metallic plate will go upwards, and it's going to be a 2-step pressing process. A pre-compactation with low pressure. Then it will open to release the air. And then we will do the final compactation with 400 kilograms per square meter. And as you can see on the video, there are no side walls on this machine. That means that any irregularity in the distribution of porcelain powder is going to be exhausted by the sides. That's why the porcelain slabs don't have any tension. That's why, well, any tension points. They might have tension, but a different type of tension that I will explain later. After we have pressed the machine, the slab, we see that we have two machines here. One on the right-hand side, so on my left-hand side, that has white bars, and this one with color bars. The first machine is to apply the glaze. The second machine is to print on the surface, okay? So as you can see on the video, it will empty totally white on the machine, and will go out with the design of a Belgian bluestone. That printing machine works the same way as a printer that we have for paper at home. Basically, it's around a set of 5,000 needles that are injecting different colors of ink, following a program depending on the pattern that we want to print. Okay, after printing, we have to go to the kiln. Here we're gonna see the interior of a kiln. Basically, we have a set of burners, lower burners and upper burners. The maximum temperature of the kiln is 1200 degrees. We have two sets of burners because we need to create a difference in temperature inside the kiln. In reality, it's 1190 degrees and 1200 degrees on the upper part. We want the gas to go from downwards to upwards, so we can collect that gas and use it to preheat the kiln. Thanks to this technology, we are able to save around 21% of the gas consumption of the kiln. Here you can see the lower burners and the upper burners. But the most important part of the kiln is this. Firing the product follows a three-step process as well. The first step of the process is what we call gas elimination. Gas elimination is because we burn organic matter on the porcelain powder, and also we burn some residual humidity. It goes from 100 degrees to 1000 degrees. Then we have the second step from 1000 to the peak temperature of 1200, in which we melt the feldspathic clay. Remember, the porcelain biscuit had two types of clay. Granitic clay gives stability during the production process. Feldspathic clay melts. Once it melts, it flows through the interior of the porcelain body and it closes the porous. We increase the density of the product, okay, and we reduce the volume of the product by 10%. That's where we can generate tension in the product, okay, because we have two layers shrinking. One is going to shrink at one rate and the other one is going to shrink at another rate. That difference in shrinkage is going to create tension in the whole product. But the benefit is that by cutting the edges, it's very easy to release that tension on this product. The last step is cooling down. Basically, after we have increased the density and after we have melted the clay, we need to solidify it again. So we use atmospheric air to cool it down. The next step will be to apply the glass fiber mesh. So we apply with a spray booth the polyurethane adhesive on the back of the slab. With the next machine, we apply the glass fiber mesh. And with the robot, we spread the glass fiber mesh, so there is a total contact between the adhesive and the glass fiber mesh, and we can guarantee a peeling strength of 50 kilos. The next machine, I have to apologize, I don't have a video, okay? It's called Qualitron. It's a machine dedicated to control the quality of the product. The quality in terms of shades, tonalities of the product, and also surface defects. So it uses 3 cameras. 2 of them are to control the shades, okay? If there is a big variation in the shade of the product between what it has been set up in the machine, it will be destroyed, the product. If the variation is slight, the machine will classify it as an additional shade, okay? Also, for surface defects, if there is any kind of dot on the surface or any kind of breakage on the side, it will discard the slab, okay? And the last step will be packaging. In our case, we work with A-frames. Okay, they are the standard in the industry. They have a capacity of 20 slabs per A-frame. We also work with wooden crates with a capacity of 7 pieces per wooden crate and easier to stock. And well, depending on the thickness and the size, you can go with one or the other. With this, I'm done with the production process. And there is one last slide to summarize everything that we have learned today. First of all, most important thing, you can call it as you wish, but it's all porcelain. That's clear. Secondly, Very interesting, we use the same raw materials as natural stone, however we can control pressure and temperature and we can obtain a product with superior properties. And last but not least, what makes me love my job is the next bullet point. We identify trends in the interior design industry. We develop the product with the highest end technology and we introduce it in the best trade shows in the world. The similarities with the fashion industry are amazing. Thank you very much for visiting us. You can get more information on our booth over there, and if you have any question, I will be happy to answer.
Thank you, Hernandez. It was a very comprehensive overview of how you go about your process. Thank you very much.
Thank you very much.